Like all high-performance homes, ours has a kitchen makeup air system. So you've got to have a kitchen hood that goes outside. All homes need that, whether you're high-performance or not. But if you're building airtight in any way, if you're aiming for any blower door test number, then you need makeup air. And I will warn you that the code for all homes generally says you only need makeup air if you go over 400 CFM on your hood. That makes no sense, and it is stupid, and they need to take it out. And if you are a code person, please know that. It has to do with the tightness of the home. This home's blower door test number is 290 CFM50. So if I had a 290 CFM exhaust hood, I would be doing a blower door test every single time I ran that. That would be super dangerous. In a humid climate, it would be dangerous for pollutants from outside and for all kinds of different things. So let's just not even get into that. You can watch other videos on this channel if you want to talk more about all that stuff. Of course, air tightness has a bunch of benefits that you can also find out about in the channel. In this video, what we're going to do is I'm going to give you a very explicit play-by-play on how a makeup air system that's an active makeup air system gets installed and then commissioned and set up. We're using the Fantech makeup air system, MUAS 750. That stands for 750 CFM. Our hood is 400 CFM. It's an exterior mounted fan, so the fan is not in your face, so it's much quieter. We also have a silencer right up here that makes it even quieter. So this is so quiet that we actually sometimes forget that it's on, and we'll walk away from it. That's a good thing, because you want to use it every single time you cook. Now, if I was going to build this house again, I would up this to a 600 CFM fan, because sometimes when we're cooking all the things at the same time, I can smell what's cooking elsewhere in the house, and it's lovely. I'm not trying to, sorry, Grace. But it's not supposed to happen. Really, ideally, you shouldn't be able to smell what's on the cooktop at the moment. So, quick guideline, we have a full video about this, but you want the makeup air to follow 3 basic guidelines that I have come up with in my practice with my clients. Don't blow the makeup air on people, don't blow the makeup air on surfaces, and don't make the circuit too long. You want to introduce the makeup air as close as possible to the makeup air hood without putting it in the hood, and I've got a video about why that's like not always a great idea. You often don't have enough room in here to lower the velocity so it's not spraying all over the place and changing the turbulence of the cooktop. Actually, a lot of the manufacturers will say don't do that specifically in their install guidelines. So we're going to go down to the crawl space because our makeup air system breaks 2 of my own rules. It's very close, and that's good, but it's coming in under the toe kicks here. And we were able to do that because my wife is patient. She's willing to deal with the fact that sometimes the floor gets sticky. It's about condensation, not blowing the air on surfaces. You're going to have a preheater in this system if you're anywhere where it gets cold, so you don't have to worry about it getting too cold down there, just too hot and sticky. And then also we have pre-finished undersides of our cabinets, so we don't have to worry about condensation because it can't affect anything down there. The floor is finished all the way to the wall as well. So let's go down to the crawl space and check that out. Unfortunately, the Fantech MUAS 750 and 1200 is kind of the only thing that we've got. So you don't have a lot of choices, and this is my plea to other manufacturers, please make something like this. It is not that hard. You've got a damper, mechanical damper. Normally closed, when it receives power, which is just a little 24-volt signal from the system, then it opens. You could buy that all by itself. You have a filter box. You could also buy this all by itself. I'm pretty sure Fantech doesn't make sheet metal goods. They probably outsource that, OEM, original equipment manufacturer, and they just rebrand it. So this is your filter. It's a 2-inch thick filter, pleated, which is very important. For filters, you want them to be as big as possible. We're moving a lot of air through this filter. So this is, you know, we want it to do a good job. This, I think, is a MERV 10 or MERV 11 filter, which is typically what comes with it. So it's not like it's gonna make it super healthy air, perfectly purified. But again, the air is only spending a few seconds in the house, ideally. It comes right in, makes a beeline for the exhaust hood, goes outside again. It should not be hanging out in your house. And that's why I never really recommend people to duct these kind of things into the central ductwork of your house, even if you're using a passive makeup air system, which is the next level down in sophistication. It doesn't do as good a job, and it's a little bit clunkier, and it's way more customized. And at this point, it's almost as expensive. This damper right here, if you get that in like a 12-inch size or a 10-inch, it's like $400. So you're gonna get 4 of those for your house. That's $1,600, and that's basically what you're paying for this kind of a setup. So filter, you wanna come in here, inspect it, clean it, vacuum, stuff like that. I can see some bugs back there in the corner. This is the most maintenance of the entire system generally. The system is hung from these collar things right here, and these come with this kit. The whole thing comes on a big pallet. Here is your fan, which is the same kind of fan as the exhaust fan. That being said, you can absolutely pair this system with any exhaust hood you want. You do not have to get a Fantech exhaust hood to pair with this. And likewise, when other manufacturers get into the game and they start doing this kind of a thing, you can pair it with whatever you want. You don't need to pair it with their same exact fan. So this one is controlled by the brain, which is up here. So we'll get into the brain and how exactly to program this in a few minutes. Between the fan and where we are is a silencer to cut down on the noise of the fan. Then we have the heater. This heater, you can see, it's monitoring 74 degrees inside the ductwork, which is the same temperature as the rest of the house, which is the same temperature as this crawl space that we're in. And I don't know if you have noticed, but this crawl space has no bugs in it. And this rolly chair thing really makes life easier down here. So disregard this. This is part of my ERV system, not part of this system. So it's just this one duct that goes through. And at this point, this heater, when it came from the factory, and I will warn you this, it was set to warm the air to 140 degrees. So when it sensed airflow, it would start warming the air and try to reach 140. That means that this 6 kilowatt toaster really maxed out every single time. And it was nice and toasty coming in on our toes, but it's totally unnecessary. You can just warm the air to like 65 or 70 and it'll be fine. It's room temperature at that point. So our bills were a little high when we first started this before I had really understood that this thing was what it was doing. So you can easily just adjust the temperatures up and down right here. So right now I've got it set to 70. This one, just quickly, because it's not super sophisticated, is not made by Fantech. This is made by Stelpro. There are lots of different duct heaters, and you can buy all this stuff online, by the way, too. You do not need to get an HVAC professional to buy this stuff for you. You can get it at a number of different websites, supplyhouse.com, hvacdirect.com, places like that. Try not to use the sites that are run by billionaires that are messing with our country right now. But this thing has a remote sensor that I've installed on it so that it's sensing way up here. Okay, last thing about the ducting is that this is an 8-inch duct system to run up to 750 CFM. It's running, if you really run 750 CFM through this system, it's moving like 2,000 feet per minute velocity. That's a lot of speed, and you do not want it coming anywhere close to your feet or your living space at that velocity, because it will literally beam across the room when you empty it into the living space, splash against the far wall, and then spend way more time in your house than you want. So you want to upsize this ductwork to slow the air down. So I've got this 8-inch upsized up there to 10-inch, upsized to 12-inch, upsized to 14-inch, going to a 14 by 14 floor grill before it empties out underneath our cabinets. So by the time it gets under the cabinets, it's moving slow enough that it can kind of find its way out without being turbulent. And that's kind of what you want, is for it to step into the room, go, where should I go? Oh, kitchen exhaust hood. And then it does that very reasonably. Okay. This is really where you want to spend your time. So this is the brain. Now, they have a new version of this system called the unitary. This one's called the modular system. I installed this myself, and many of you are going to have to do that too, because your local HVAC professional is not going to want to learn something new that he's only going to do on one house and then never again in his local area, because you're probably asking for special stuff. Let's face it, all of us are kind of a pain in the butt. So this thing, plus the fan, plus the filter, is what is packaged in this new unitary system. That unitary system is $800 more than this entire system. And you still have to buy that damper, and you still have to buy this silencer. They have wrapped the unitary, the box itself is insulated, which is good for like machine noise, but honestly, this fan is not that loud. What you're gonna hear, the noise you're gonna hear, is down the duct coming out of the duct itself. So that is what this is for. So this is another $150 on top of that, plus the damper, plus the preheater, which is not included on either system, is optional. So the brain should work exactly the same way in both systems. Let's come in real close and take a look at this. What tells this brain to turn on in the first place is a wire that's running along and leading to that right there, called a current sensing switch. Inside the box is this thing, which looks like a donut, basically. Called a current sensing switch, and you can see on it that it can sense input current 100 amps max. That's insanely high, which is part of the reason why I have a hard time sensing really, really low flows on my fan. So you'll see that in a minute. But the output signal is 0 to 5 volts DC, 0 to 10 amps. You can see that you've got the little connectors right there. That's the only electrical connection you make, and then that goes back, and it's basically an open closed circuit. So I used little fancy connectors in there. The yellow wire is the exhaust hood. Gets spliced. We run the white through as many times as you can possibly get it through there before you run out of room, and then splice everything back together, and you can see it leaves here again. I got some more sophisticated versions of this current sensing switch, which RIB Building Automation. I met them at the AHR Expo, and they very nicely were just like, hey, here, take a couple of these, see if these work. This is nice because you don't have to cut the wire necessarily. You could just have one wire and you don't have to splice it at all, and you just basically, move that. So that's kind of a nice feature, but you still probably would want to have as many of those loops as possible because you just want it to pick up very, very small. This one is made for EC motors, so it's expecting to see a variability in the current. The labels that you see here are for the wiring block on the left. So that's where the range is, and it'll activate it at different speeds. That's one of the strengths of this system, is it'll dial to whatever CFM it needs to be. So we're going to need to program the 2 points at the end of the curve. We're going to need to program the highest flow that your exhaust fan can do and the lowest flow. And then this brain will say, oh, I'm reading a current that's here on the curve. So I'm going to deliver what I know that CFM must be at that point. So on the right over here, we've got 2 buttons here. I'm going to need a screwdriver like this to be able to go in and press that button. So I'm going to press the top button. As you can see here in the manual, we've got the high set and the low set are the 2 buttons. So the top button is when I've reached the highest velocity or the highest speed that my fan is going to run on. It's pumping the most current. I'm going to press that button and say to that is the highest that you're going to see. So that's your now high speed. Then we're going to turn it down. We're going to press the low button and say that's your low speed. Then we're going to dial it in. And actually, you can do it all at the same time. It's fine. The manual has you do it in 2 separate stages. So at that point, we will use this screwdriver to dial these little screws, which are these high trim and low trim. Those are just little potentiometers that you use the screwdriver portion of this to actually turn the dial. And we're going to be monitoring the pressure in the house with reference to outside. Right now, I've got the whole house open. So right now, it's almost like we are in the kitchen, even though we're in the crawl space. That's very important. So if you're in the attic hatch is open, et cetera, et cetera. You can see our house is floating a little bit negative. That might be wind. I've had some issues that are recurring with our ERV balancing, and then also with the radon system. And we've been exploring that on this channel a while. So don't worry about this too much. This is our baseline, is -2. So we'll try to land back at -2 or even all the way back to 0, because the goal when we run our kitchen exhaust is that this number is 0, no matter what speed we're running the kitchen fan at. We want the pressure in the house with reference to outside to still be equalized, and that's what this system is here for. We're going to go ahead and kick the kitchen exhaust fan up to its highest speed. Now, because this red light is solid, it means it's got power and all of the wiring that we did was correct, and it's blinking, it means it's ready to be programmed. You can see that we're running a blower door test with the kitchen exhaust hood right now. And I told you that our blower door test score for the enclosure of this house is 290 CFM50. So at 50, it would be 290. We're at 54-ish, so it's probably something like 310, 320. That kitchen exhaust hood is rated for 400 CFM. So what's really happening here is that thing cannot deal with the fact that we're giving it such a hard time finding air to replace the air that it's sending outside. So it's not running at 400 CFM right now, even though it's on its highest speed. It will in a moment as soon as I give it some air, so it doesn't have to work hard to push air and pull air at the same time. So first thing I'm going to do is press this button to program it. That is the highest speed that you're going to get. you might be like, did I actually push it or did I imagine it? Just push it again, it's fine. Now I'm going to use this potentiometer to run this fan up, and you'll start to hear that the fan over here starts running. So, interestingly, I have maxed out this supposedly 750 CFM makeup air fan, trying to push against a 400 CFM exhaust fan. Probably that exhaust fan over the hood is doing better than 400 because I've ducted it with a bigger, nicer duct, an 8-inch duct. Always do that. 400 CFM, 8-inch, 600 CFM, 10-inch, 800 CFM or 1000 CFM, 12-inch. So we've got a lot of flow up there, but the fact that we're not even able to get back to my original -2 number here means that I suspect that my duct might be clogged. So stay tuned for a duct cleaning video. I'm going to get more into duct cleaning because the bugs and stuff like that in Atlanta really start to clog this stuff up. All this stuff takes maintenance. This does not make your life maintenance free at all. It makes it better, but it's still work. So at this point, I've maxed that out, the high potentiometer. Now we're going to go down and do the low. Not off, that's off. This is low. It's very quiet. And now we're running at low speed, and you can see, now when you turn it down, this machine should, if it's doing what it should do, should automatically shut off because it's not reading that current anymore. And so it's like, oh, I'm not at my high speed. I haven't been told what my low speed is yet. So now we can program this. So we're at the low speed. I'm going to go ahead and press this button so that we know that we're at the lowest point that it's going to sense. And then I start turning up the low potentiometer, which is the one underneath the high. Aha. Okay. So this is that problem that I was mentioning earlier. This thing actually isn't sensing current from the hood at all yet. Grace, would you go up and just try and turn it a little bit higher?
A little bit higher.
Yeah, this is where using that more sensitive current sensing switch would be better. And I will be making that improvement, but I can't make everything into one video. So we lost our light. We're changing stuff up. Okay, it should look a little bit different. Right now you can see I've got it on the low speed. I'm gonna go ahead and activate that and tell it this is the lowest it's gonna get. I've got the low potentiometer turned all the way up, and you can see that I can pressurize the house a lot. So that's too high, and it's always good to see what this thing can actually do. So I'm going to turn it back down. And I'm able to get the low speed to actually equalize the house down to, 1-ish. Maybe I'll open it back up a little bit. Now, this is a very nice manometer. Manometer is a pressure gauge. You don't necessarily have to have one that's this nice. This is a $400 tool. I highly recommend this if you're a really serious homeowner trying to get home performance right. You should have something like this. But if your HVAC professional is using something that's like a field piece or a, another HVAC brand that's measuring in inches of water column, not pascals, that would look like this. And you can see that at basically zero, I'm at 0.0036 inches of water column. Most of those gauges that they might be using, if they're digital, might have 2 decimal places. So this is going to be way more kind of fine-tuned and nitpicky, which I think is worth it. But again, if they're using something and they get to like 0 on the gauge, it's going to be in the neighborhood of 0. And you can see that I still need to do some work on this after I do my duct cleaning. I'll need to come back down here and do this again because the fan performance will be wildly different potentially at that point. So again, I hooked up this system entirely by myself. It took me about a week to get it right because I am not an electrician and I'm not an HVAC professional. So I believe in you. If you have to do this yourself, you can. And if you need help, you can obviously get on a consult or coaching with me at buildingperformanceworkshop.com. So if you're an HVAC professional and you think you can cobble something like this together, I believe in you too, because you can. It's not that hard. There's all these parts come in individuals. So I've got clients who are absolute rock stars and are like, hey, I have a better idea for that. And I think that's great because, yeah, the manufacturers only think hard enough and engineer hard enough so that they can start making money off of it from as many people as possible. And if you have a custom thing that you're thinking of, you should pursue that. I think that that's totally worthwhile. So I hope that you've enjoyed this. Please do comment below if you have anything else to add about this system or other makeup air systems like it that you've seen. Like and subscribe. Tune in next time.